Today's main focus is mathematics. We are going to talk about number pattern. This is lesson 101. Let us start. Number patterns, sequences, and series. Today's main focus, we are going to look at number pattern based on grade 12 syllabus. Number patterns. Number patterns are a list of numbers in order, which is called number pattern or number sequence. We need at least 3 numbers in the list to work out if the numbers form a pattern or not. If we only have 2 numbers, we cannot be sure what the pattern is. So, in order for us to determine whether numbers are patterns or not, we need at least 3 numbers. Having 2 numbers, it's almost impossible, or we cannot be precise or 100% sure that we are dealing with number patterns. Let us look at general examples. Looking at these 2 set of numbers, we have set number A and B. Looking at set B, we can see that we only have 2 numbers. It's difficult for us to be sure whether this is a number pattern or not. We can see that to obtain term number 2 from term number 1, we added 2. So 2 plus 2 is actually 4. But we are not sure that the next number, when we add 2, it will give us the next number. The problem is that we don't have the next number, so it's difficult for us to actually be sure or conclude that this is number pattern. Now looking at set A, we can see that for us to obtain term number 2 from term number 1, we added 2. So 2 plus 2, it will give us 4. Looking at term number 3, we can see that from term number 2, we added another 2 to get term number 3. So we can conclude that this is a number pattern. We can see the order of this number pattern. It means for term number 4, we are going to add another 2, which 6 plus 2, it will give us 8. I hope you can see the trend. Today's main focus is one type of a pattern, which is arithmetic sequences or arithmetic pattern. We have different types of number patterns. Make sure you look at the next consecutive lesson videos, which is lesson 102 and lesson 103. Now, what is an arithmetic sequence? Arithmetic sequence is a sequence where the common difference D between consecutive terms is constant. Now, this simply means that the difference is 2 numbers. Actually, it's a result whereby we subtract 2 numbers. So term number 2 minus term number 1, it will give you difference. Term number 3 minus term number 2, it will give you the very same difference. So these terms should be the same for us to conclude that the given sequence is arithmetic. Let us look at this given number pattern. What is the difference of these terms, or what is the common difference? Now, in order for us to get the common difference, remember we must use these equations. Now, term 3 minus term 2, or we can start from term 4 minus term 3. It will give us the difference. So term 4 is 17 minus 13. Remember, this is term 1, term 2, 3, and 4. So we get that 17 minus 13 is 4. So the difference here, we get 4. Let us proceed. We look at T3 minus T2. So T3 is 13 minus 9 is equals to difference, we also get 4. So the difference here is 4. Looking at T2 minus T1, 9 minus 5, it will also give us 4. So you can see that the common difference, actually the difference is common. If the difference is common, then we conclude to say this is an arithmetic sequence. Let's say there's a question saying determine the next 2 terms. So for the next 2 terms, we can simply add 4 from 17. 17 plus 4, it will give us 21. Then 21 plus 4 again, it will give us 25. So the next 2 terms is 21 and 25. I hope you can see this. Let's say we are given this type of a pattern, and then we can quickly prove that this is a arithmetic sequence. 16 minus 10 is 6. 10 minus 4 is 6. So the difference is common. Now there will be a question, or let's say we have this question whereby we need to determine term number 50. So this is term number 1, this is term number 2, this is term number 3. So we go on up to term number 50. We need to know that term. We see that if we use that method of adding 6, 6 and 6, we are going to take the whole day. So there is a way or a certain formula for us to actually calculate numbers of any position. Each and every type of a sequence, it has a general equation. Now the general equation is made up of the first term, which is represented by letter A, and then it's also made up by the common difference, which is represented by D. That equation is Tn is equals to A plus n minus 1 D. You need to know that n represents the position of a term. So n1 is 4, n2 is 10, and 3 is 16. So you are actually looking for n50. So in order for us to get n50, we need to use this general equation and determine the equation for this specific number pattern. So from here we have Tn is equals to the first position. Actually the first term, the value of A is 4. So we are going to put 4 plus n minus 1. Our difference is 6. Then we can quickly simplify the bracket. 6 multiplied by n, 6 multiplied by negative 1. 6 multiplied by n, we have positive 6n. 6 multiplied by negative 1, it's negative 6. From here we can see that the like terms is 4 and negative 6. So we have 6n, 4 minus 6 is negative 2. So this is the equation for this number pattern. We can quickly prove or check whether the equation works. So let's say we are looking for term number 1. We can see that term number 1 is equals to 4. So where we see n, we put 1 to represent position of that term you're looking for. So it's T1 is equals to 6, 1 minus 2. So 6 multiplied by 1 is 6 minus 2, that is equals to 4. So term number 1 is equals to 4. We can quickly prove term number 2. T2 is equals to 6, 2 minus 2. That will be T2, 6 multiplied by 2 is 12 minus 2. T2 is equals to 10. So we can see that term number 2 is indeed 10. So back to the question. The question said term number 50. So we needed this equation in order for us to determine term number 50. So you listen. To determine term number 50, where we see n, we substitute by 50. So it will be T50 is equals to 650 minus 2. So T50 is equals to 6 multiplied by 50 is 300 minus 2. 300 minus 2 is 298. So the answer is 298. The term which occupies position 50 is 298. Let's say we have another question saying, which term of the sequence is equals to 310? So we are looking for the position of 310. We are given the actual term. So we are still going to use our equation for this sequence. So we need the position of this number. In order for us to do that, we substitute Tn by the term we are actually looking for and solve for n. So it will be 310 is equals to 6n minus 2. And then we transpose this to the side. We have 310 plus 2 is equals to 6n. 310 plus 2 is 312 is equals to 6n. We divide both sides by 6. This will result into 1 multiplied by n is equals to 312 divided by 6, it's 52. So this means 310 is term number 52. T52 is equals to 310. Let us look at another example. You can go ahead and pause this video and try to work out these questions and find the answers. You play the video to verify. Now the first question, calculate the nth term. Don't be confused. Nth term is the same as the equation for this arithmetic sequence. And then the second question, calculate term number 21, the 21st term. And then question number 3, you calculate the position of 97. So pause the video and then you will play it and verify your answers. So to calculate the nth term, we need the first term and the difference. So 20 minus 13 it's 7. 13 minus 6 is 17, it's 7 actually. So we have Tn is equals to A plus n minus 1 D. Tn is equals to 6 plus n minus 1. Difference is 7. Tn is equals to 6 plus 7n minus 7. Tn is equals to 7n minus 1. So we are done with the first question. For the second question, we actually use the very same equation. Where we see n, we substitute by 21. It's equals to 7, 21 minus 1. T21 is equals to 7 multiplied by 21, it's 147. 147 minus 1 is 146. So term number 21 is 146. I hope you got it correct. Let us move to the next question. The next question is saying we need to determine the position of 97. So where we see n, we substitute by 97, it's equals to 7, n minus 1. And then we have 7n is equals to 97 plus 1. 7n is equals to 98. We divide both sides by 7. N is equals to 14. So term number 14 is 97. I hope you got these answers correct. Here's another one. Pause the video, work out and play the video. We are looking for term number 15. So as usual, we need to work out the equation. So it's Tn is equals to the first term, it's 8 plus n minus 1. 2 minus 5 is negative 3. 5 minus 8 is negative 3. So it is possible for the common difference to be a negative number. Negative 3 multiplied by n, it's actually negative 3n. Negative 3 multiplied by negative 1 is positive 3. Tn is equals to negative 3n plus 11. So to calculate term number 15, where we see n, we substitute by 15 plus 11. Negative 3 multiplied by 15, it's negative 45 plus 11, the answer is negative 34. So term number 15 in the sequence, it's negative 34. So it simply means that when we continue up to term number 15, we are going to get negative 34. So the second question, we need to calculate the position of negative 289 using the very same equation. Where we see Tn, we substitute by negative 289, it's equals to negative 3n plus 11. Take this to the side. Negative 289 minus 11, it's equals to negative 3n. We divide both sides by negative 3. This will result into 1 multiplied by n, it's n. Negative 300 divided by 3. Negative 3 actually it's 100. Remember, position cannot be negative. We don't have negative 100 as a position. So just make sure that the value of n, whenever you are calculating involving negative numbers, you get a positive number when it comes to n. I hope you got this one correct also. This question is a bit different from the previous ones. We are given this arithmetic pattern. The first term is 1 minus p. The second one is 2p minus 3. The third one is p plus 5. The first question, solve for p. In order for us to solve for p, we need to understand the principles of arithmetic pattern. We said that the difference should be common. So this means when we minus these two terms, this term minus this one, it will give us the very same answer as minusing this term and this one. So when we calculate the difference, it will be 2p minus 3, which is, this is term number 1, term number 2, term number 3. So term number 2 minus term number 1 minus, we put inside the bracket 1 minus p, and then we also have p plus 5 minus 2p minus 3, t3 minus t2, t2 minus t1. For us to say this difference is common, it simply means that whatever number that we are going to get here will be the same. This number is equals to this one. So from here we can say 2p minus 3, we multiply this and this to simplify the bracket. So we are going to have negative 1 plus p, it's equals to this, p plus 5 negative multiplied by this, it's negative 2p positive 3. We take all the terms, like terms, one side. So this, and this one side. So we are going to transpose this term to the side and also this one to the side. This term, this one, and this one, this one. Going to take this ones to the other side. So we have 2p plus p. This one is positive. When it comes this side, it becomes negative p. This one is negative p. When it comes this side, it will become positive 2p. It's equals to, we have 5 plus 3. It's this term and this one. This one it was negative, and also this one it was negative. So we have plus 3 plus 1. 2 plus 2, it's 4. Plus 1, it's 5. Minus 1, it's 4. So we have 4p this side. 5 plus 3, it's 8. 8 plus 3, it's 11. 11 plus 1, it's 12. So we divide both sides by 4. This will result into 1. 1 multiplied by p, we have p, it's equals to 12 divided by 4, we have 3. So the value of p is 3. Now from here, the question says determine the first 3 terms. So this is the given arithmetic pattern, and then we did determine, we found the value of p equals to 3. So for term number 1, it's equals to 1. Where we see p, we substitute by this, minus 3. This will give us negative 2. Term number 2, it's equals to 2. Where we see p, we substitute by 3, minus 3. So 2 multiplied by 3, it's 6. 6 minus 3, it's 3. And then for term number 3, p plus 5. So we have 3 plus 5 equals to 8. So term number 1 is negative 2. Term number 2 is 3. Term number 2 is 3. Term number 3 is 8. So we have negative 2, 3, and 8. That's it for this lesson video. This is Bahula SJ. Thank you very much.